I hope my screen is visible. Just message me in the chat box. Yes. लाइट ही गई वही तो प्रॉब्लम आ गया अदरवाइज एक्चुअल करने वाला था अब उल्टा करना पड़ेगा करूंगा डेफिनेटली इसलिए तो ऑनलाइन बोला है कि यहाँ पे जो मैं लिखूंगा वो पास होगा और आवाज तो वैसे भी रिकॉर्ड हो ही जाएगी लेकिन प्रॉब्लम हो गया कि लाइट चली गई अब टैब पे ही लिखना पड़ेगा और वही अब स्क्रीन कास्टिंग ऑनलाइन अभी मतलब शुरू तो किया है कोई प्रॉब्लम डिस्कस नहीं किया कुछ देर के लिए ऑनलाइन कर लो जब तक लाइट नहीं आती आपको क्योंकि गर्म बहुत हो रहा है Misha and well I am the deputy with this I'm not using my own account Father's account maybe create here well we need the wallet so that I don't well I will join through mobile also so that did I deleted the teams at least I can see the record so nearly first 5 minutes are and I won't be editing the video I will skip 5 minutes I will just write that in the instruction that you have to skip first 5 minutes to get the so this is just same consider same as your imparts instead of recording by imparters we are recording your voice so join the meeting so many of you might have seen the title okay I will share the attendance sheet of CSE unaided and aided all of these things why I guess 3 attendances and the last sheet that I'm sharing with them is tentative lecture plan and what we have covered in the lecture. And since it might be the case that we have a lot of interaction, so I will just add one more column in which I'll just make as a title I will CSA aided and ITI aided, and I will write down the lecture content covered, maybe online, maybe offline, in that sheet, and I will ask in the lecture. If you miss any lecture, you know what to see. That was the goal, and what are the upcoming lectures? That also you can have an idea, a little idea. Well, the titles are at just the beginning they are given as per the PDF syllabus PDF, but later on while writing the notes, I changed the titles. according to what my tentative lecture plan should be. Okay, so for fifth and sixth chapter, they are just simply uh, I whatever those given in the PDFs, the names whatever given in the PDFs, mostly those will follow, but in some cases, little here and there I will make. Okay. So as you might have seen, the title that we are going to discuss was not we are still discussing homogeneous, right? Homogeneous linear differential equations. Right. So in the last lecture, we have seen both the classes quadratic equation or degree 2 equation, order 2 equation, right? Order 2 homogeneous equation, order 2 homogeneous equation. Now, what instead of order 2 homogeneous equation, well, you can use this tool. So instead of order 2 homogeneous equation, what if we have degree n homogeneous? Trying to generalize whatever the result that we have discussed for degree 2. Okay, we will be generalizing whatever the result that we have discussed for degree of the equation will be. Sit to your mobile. I know this is not saying. Well, I said you can bypass the lobby. Everyone can bypass the lobby. I have made that setting. Okay, where are the light? नहीं है यही problem है. Otherwise, I would have used this board, but that will not do anything in the online. That's why the best way to do it. But this is that we have right now. I don't know if my net is slow. I'm using 5G, but still it is not catching up. Okay, who can? Okay, you might be using that your own Gmail account. But okay, I have changed the setting. You can bypass the lobby now. Try once. Well, the default setting is that you can bypass the lobby only if you are using the college FD. But no, you can just join in right now. You need to sign in because I have changed the access. Join, and if the screen is visible. Till that time, I will also join the Microsoft Teams so that I can see the chats. So CSE I did have a lecture at 11:15, right? So either that will be taken by Zamadar ma'am or it will be off because I do have a lecture at the same time. I can't. Okay. I hope I can use any account. Okay. I'm also joining using that link, same link. I'll turn off my audio in this one. Okay. Those who are sitting here, you don't need audio. Why my screen is not visible? Okay, screen is visible. Okay, that's what I want to see. I also want to see the chats. Okay, yes. Now you can bypass the login and join. Right, I have joined using my Gmail, so I can do that. So in the previous lecture, we were discussing homogeneous differential equation of order two with constant coefficients. What do we have to restrict ourselves to order two? We can have order and equation. So that's what I'm going to see right now. So homogeneous linear differential equations, but again with constant coefficients. With constant coefficients. Okay. So in this types of equations, the general form will be, or the general form is Pn d power n by dx power n plus -1 d power n y by d power n minus 1 y by dx power n minus 1 and so on till we get p1 dy by dx plus p naught y is equal to 0. Okay. So order 2, we are having order n equation. Instead of order 2, we are having order n equation. The same equation in operator form can be written as the same equation in operator form. Do you remember operator form? Remember operator form? D representation. By that I mean I am taking derivative with respect to x, and what will be, it will be integration with respect to x, right? So this equation, same equation, in the operator form is given as Pn d power n plus n minus 1 d power n minus 1 n minus 1 plus so on till we get P1 d P naught whole times y is equal to 0. Right. Again, I will call this as equation 1 because this is the same copy of equation 1, but just in another form. Or you can call it as equation 2 if you prefer. Now, what is the auxiliary equation corresponding to this equation? What is the auxiliary equation? We just have to replace d by n. And whatever the polynomial that we are getting, that will be our auxiliary equation. The corresponding auxiliary equation corresponding I'll use that short form AE for auxiliary equation again. So the corresponding auxiliary equation for 1 is how I am getting replace D by M in operator form. This is how I am getting my auxiliary. So I will get Pn m power n plus Pn minus 1 m power n minus 1 and so on till P1 m plus P naught is equal to 0. So let's call this as equation number. So my auxiliary equation is equation number 2. Okay. Again, how to solve this equation? That's our goal. Our goal is to solve these types of differential equations, right? So these types of equations. To solve equation 1, we follow We follow following algorithm. Following algorithm. Similar to the previous case, we will have an algorithm which is designed to solve these homogeneous differential equations. So the first step is extract auxiliary equation that we have done in an about equation. Replace d by m. Write the equation in operator form and replace d by m. And if you are comfortable, you can directly write down the auxiliary equation. Okay. Then the next step, solve auxiliary equation. Solve this auxiliary equation to get n roots. I'm not mentioning anything about the roots. So they may be real, they may be complex, but what I know about the roots, there are n roots. Definitely n roots. Even if my polynomial is m minus whole cube, one is a root. Okay, but one is repeated 3 times. That's why 1, 1, 1. I have 3 roots. Okay, that's how I'm counting. I'm counting with multiplicity. And that's why I know I do have n roots. Even if my polynomial is x cube minus 1 is equal to 0. In that case, 1 is only repeated once. But I do have quadratic polynomial when I factor out that 1. I have x square plus 1. And that has complex roots. Right? That they do have complex roots. So what I'm saying that there will be 3 roots. No matter the case, there will be n roots for degree. Maybe repeating, I'm counting with the repeated for the numbers they are repeated. So I will have n roots. Third one, find solution component. I am not saying total solution component for each root, and finally the total solution or the final general solution is summation is the summation of all components. Summation of all components. So I guess step number 1, 2, and 4 is clear. The only thing that we are going to see what is meant by the solution component for each root, right? So solution components. What are those? So I know there are 3 types of roots, right? There are 3 types of roots. What are the 3 types of roots from my previous case? First one, they are distinct. I mean, they are repeated only once. Second thing, they were repeated twice in my card. In general, I can say they are repeated k times. Right? They are repeated k times. And third one is they are real. That's why they are complex. But there are some complex corresponding to that. Okay, these are only the 4 types, 3 types. And there, I can consider one more type. I can combine second and third. That there is a complex root which is repeated k times. There is a complex root which is repeated k times. So I have these 4 types of root. Either they are real and distinct, complex and distinct, or real and repeating, or complex and repeating. So for each case, you have solution components. And the number of components they provide is equal to the multiplicity of the. By multiplicity, I mean how many times they are repeated. If a root is repeated k times, k can be 1. If it is distinct, it is 1. So if a root is repeated only once, in that case, it will give me k roots, right? If it is repeated once, it will give me 1 root. If it is repeated 3 times, it will give me 3 components corresponding to that root. And I will calculate the component corresponding to each root. So if I'm having the same number of components as the multiplicity of a root, how many components I will have in my general solution? Just a guess. Can you guess that? If counted with multiplicity, I have n roots. How many components I will have in my solution? N, right? Notice that we need to have, or we need to count all those n components. Okay. So first case, a root. Let's say mi is real and not repeating. By not repeating, I mean it appears only once. Appears only once. Right. A root mi is a real root and it appears only once. In that case, the solution component corresponding to that root is yi is equal to ci times e to the power mix. Notice the similarity between what we have done before. Notice the similarity. We have nearly the same root. When our root distinct roots, the first solution component was c1 e to the power m1x and second component was c2 e to the power m2x. And addition of these two, I'm just generalizing those results. Okay. Now, the second case may be a root mi. A root mi is again real, but repeated k times. But repeated k times. Right? K can be also 1. Actually, first case can be considered here also. So in that case, my solution component is yi is equal to ci1 e to the power mix like the previous case. But what was happening if my root is repeated twice? What was happening if my root was repeated twice? I was adding an extra x, right? The second term was ci2 x into e to the power mix, right? Now, instead of 2, what will happen? I generalize this series. This is something looking like series. So I need to increase the power of k, power of x, till I get my k components, right? No, x raised to k minus 1 because I am starting with x power 0. So this will be ci3 x square into e to the power mix plus so on till I get cik x power k minus 1 e to the power mix. Okay. I'll get the k component corresponding to these roots. I'll get k components corresponding to these roots. Now, the third case, a root mi is a complex conjugate. A root mi is complex, which will definitely imply there is mj which is mi conjugate, right? If I have a complex root, conjugate must be a root, right? So because of that, a root m is there, and there is definitely mj which is conjugate of mi, and in that again I will consider the first case as mi appears once. Mi appears only once, or mj also appears only once. If mi is appearing once, mj has to appear only once. It cannot appear twice. Now, this is quite same case as our quadratic condition. We have two roots which are complex conjugates of each other. Right. In that case, we have a solution in terms of sine and cosine. So, here I will write down my mi as a plus ib, so that mj will be a minus ib, right? Because so solution component corresponding to that root is yi is equal to ci e to the not ci a to the e to the power ax ci cos bx plus cj sin bx. Notice that we were accounting for two roots, mi and mj. and we are having two components, not just one. There are two components, right? In total, I will have X components in my solution. Now, the second case in that can be the second case in the same equation can be mi appears mi appears, let's say k times. What will happen if mi appears k times? Again, the same case. I need to add those extra x's. I need to add those extra x's. So in that case, my solution component yi will be again e to the power ax, but here I will have ci1 cos bx plus ci2 x into cos bx and so on till I get cik x power k minus 1 cos bx, and then in terms of sine cj1 sin bx plus c2 x into sin bx and so on till I get cjk x power k minus 1 sin bx. Right. How many roots are there? Or how many components are there? Can you count those components for yi that I have written? Only directly to k, not minus 2. Okay. Here, yeah, I have started from 1 and indexing is ended at k. So, we're starting from power 0 and ending at power k minus 1. So, the k components in each row. Then these two rows will give me 2k. Notice that I was counting for roots also. Mi was repeated k times. That's why mj must repeat k times. Because for every complex solution, its complex conjugate has to be a solution. Because of that rule, since mi is repeated k times, mj will also repeat k times. And that's why I had k 2k components as my root, k numbers as my roots. Corresponding those many roots, I have my 2k components. And I will all the four types together to get my complete solution. All those four types I will add as my complete solution. Now I just need to see some example. Okay, I will just take this from. I guess I have shared this notes with. Okay, consider this example. Well, there is nothing to do much for this lecture at least, because whatever we are doing, well, just we are going trying to solve the quadratic equation or cubic expression, quartic equation. But again, we cannot solve quartic equation, cubic expression generally. We'll be focusing on. Uh, I mean, I'll just give you the solutions. I mean, not give you the solution exactly, but those solution will be definitely lying between minus 10 to 10. Why minus 20 to 10? Because you can calculate using calci, and that I will show how here only. So this is not y. This should be 4 times, I guess. Or okay, no. This is dy by dx directly. Dy by dx and plus 3y is equal to 0. Okay. Consider this equation which we want need to solve. Again, the given equation is the given equation is e cube minus 3d square minus d plus 3 times y is equal to 0. I am writing the equation in operator form. So I am replacing the order of differentiation by d power d degree of the same thing. Right? Now I can write down my auxiliary equation. So therefore, so I'll call this as, let's say, equation 1 for above 1. It's better to name the equations. Therefore, the auxiliary equation is m cube minus m square minus m and plus 3 is equal to 0. Well, I can see 1 is my root. Alternating signs I can see. Right. But suppose I'm not able to see or identify those roots. I'm not able to identify those roots. So in that case, what I will do, I'll open my calci. I will open my calci. Take out your calci so that you can practice this with me. Because this will be an important task. Because for even for the non-homogeneous solutions, we have to go through the homogeneous solution first. Well, they are independent of each other, but it's better to know. And if you don't have your calci, you can try it on your mobile. You do have app, right? I hope you are using the same app as me for calci, but it's better to have it on physical calci. So you can see the mode on the first column or first row, right? So click on that mode and select the table. Select the table. You will have at least, I guess, number 3 per table. It depends on calci to calci. Some calci says at number 2, some calci says at number 3. So it will ask you for f of x. So give the same function as your f of x. Notice that our function was in terms of m, but we want to give it in terms of x, right? So give the same function as your f of x. So here x is given at, consider that closing bracket. Wherever your closing bracket is, so that maybe here, in my case here, you can see, right? So press alpha and that closing bracket, you will get the x. Where you have that x, just letter x, alpha and then closing bracket, alpha and that closing bracket. What happened? Okay. Okay. After getting your x, you know how to get x. Then write down the whole equation. The whole equation was x cube. So x cube. I made the mistake. So x cube, and we have minus 3x square, and then minus x plus 3, right? After entering your equation, minus 3x square, okay. Minus 3x, after entering your equation, press equal to the final solution that we calculate. Press equal to, in my case, it is asking for g of x, which will not ask you, well, we don't need also g of x. So where to start? Let's start at minus 10. Start at minus 10 and end at plus 10. End at plus 10. Okay, start at minus 10, end at plus 10, and step length should be 1. Step length should be 1. Simple 1. Then, after pressing this final equal to, you will get a table. You are getting a table. So wherever your f of x value is 0, that's your solution. So I guess, okay, minus 1, you are getting 0. Okay, you are getting all the 3 solutions. You are in this case, you are like, you don't have to go for quadratic, splitting the middle term, all those things also. So we were trying to calculate only one solution because that's what we want to factor out, and rest can be calculated using quadratic formula. And this will be always the case. At least even if I am giving you a degree 5 equation, 3 solutions will be lying between this interval, minus 10 to 10. Okay, so that you can calculate easily. So I have my 3 solutions. Well, in this case, I am lucky. I am getting minus 1, 1 and 3 as my solution. So I'll just mention that as a comment that using calci, m is equal to -1, m is equal to +1, and m is equal to, well, after this problem, I was planning to shift there, but I guess this is not going to happen. So using calci, these three are the solutions. Are the solutions, right? M is equal to -1, m is equal to 1, and m is equal to 3. These are the three solutions. Notice that I am giving you a lot of time to calculate this homogeneous solution. But in the upcoming lectures, I will just assume that you are able to do that, and I will be focusing on how to calculate particular integral. I'll just give you the final solution, a final form of this homogeneous version. But I'll assume that the in between these calculations are done by you. Can be done by you. If you have any doubt, you can definitely ask. But I will not do in the class, or no one will do, because we have to cover up different types when we have non-homogeneous on right. My homogeneous right hand side and right hand side is 0. Okay. So these are the solutions of my auxiliary equation. So therefore, the general solution, you can write down the general solution directly. You don't need to write down the component for this root, component for this root. Just write down the general solution directly. The general solution is y is equal to, what is the solution component corresponding to my first root? M is equal -1. M is equal to minus. So what is the solution component? It will be C1 e to the power minus x. Minus this m value is -1. Then for second root, I have C2 e to the power x, and C3 I have C3 into e to the power 3x. Okay. I'll directly jump to the solution where I have my where are those roots? I have a condition where the roots are, I mean, different types of roots. Okay. Consider this example. Consider this example where I have y to the y taken the fourth derivative. So y4, then this third derivative, then minus 2y double dash plus 2y dash 12 is equal to 0. So it's a degree 4 equation. It's a okay. So I'll rewrite this equation in the operator form. The given equation is d power 4 minus 3d cube minus 2d plus 2d plus 12 times y is equal to 0, and therefore my auxiliary equation is m power 4 minus 3m cube minus 2m square plus 2m plus 12 is equal to 0. Okay. Y should be multiplied. Y should be multiplied. Did I make that mistake here while writing? Yeah, here I have made that mistake. Y should be there. We're talking about non-homogeneous first. That's why that Y will be 12 will be multiplied by Y. If it is not multiplied, how to solve it, we will see in the next lecture. Actually, when right hand constant or exponential. Constant can be seen as e to the power 0x. Right. E to the power 0x into the same constant. Okay. Again, assume my roots. I'm not able to see the roots, right? So what I will do, I will go to the calci. I'll go to the calci and solve this equation. And so what is my equation? This is x power 4 x power, then we have minus 3 x cube minus 3 x cube. So minus x cube, not x cube. Then minus 2 x square. I'm doing minus 2 x cube and finally plus 12. Not plus 12. Is 2x plus 12 and right. 4x cube minus 3x square plus minus 2x square plus 2x and plus 12. Okay. So again, I'll consider my range from minus 10 to 10 with a step length of 1. Get my table in which I'll get 2 and 3 as my roots. Only 2 and 3 as my roots. None of these values except 2 and 3 are the roots. Only 2 and 3 are the roots. Okay. So I got only. So I will divide by x minus 2 and x minus 3, and I will end up with a quadratic equation solve by my usual method. Okay. Yeah. Yes. Other quadratic. Yes, that what. But I will not divide by quadratic directly. I'll first divide by x minus 2 and then I will divide by x minus 2. So use my synthetic division efficiently. Yeah, I will be using synthetic division. So first, let's say I'm dividing by 3. Let's say or 2. Let's say I'm dividing by 2. So do you know synthetic division? Write down the coefficient in decreasing order, right? And write down the root on the left hand side, and and first coefficient as it is. Multiply the first coefficient with the root, add those whatever the values that you get, and repeat the process. Repeat the process till you get the last point, where the last value will definitely be, that's the remainder. The last value will be the remainder. And the coefficient that are showing are again in the decreasing order, starting if my equation was x power 4, it will be from x cube. And now I need to divide the same equation by x minus 3. So repeat the same process. So 3 into 1 is 3. I will get 2 here. 2 into 3 is 6. So I will get plus 2 here. And 3 into 2 is 6. So I'll get in 0. So what are my coefficient of the quadratic equation? So I will write down these two brackets, m minus 2 and m minus 3. I know these are the roots. And the remaining thing is x square plus 2x, not x square, m square 2m and 2 to 0. Notice that I cannot split the middle term. But is less than 4 is. Right. Discriminant is negative. Since my discriminant is negative, I need to go for quadratic solutions. Those quadratic formula. So to get my these remaining roots, I have m is equal to minus 2 plus or minus b square. In my case, it is 4 minus 4ac, that is 2a. In my case, it is 2. So I have minus 1 plus or minus. This will be minus 4. So iota. Right? 1 iota. So value of my m is minus 1 plus minus iota. So therefore, the roots are, what are the roots? M1 is 2, M2 is 3, M3 is minus 1 plus iota, and M4 is minus 1 minus iota. Right? I have these core roots. I have these core roots. Now, I need to write down my general solution. And to write down my general solution, I need to add up all the solution component corresponding to each root. So I'll try to add those components. Therefore, general solution, the general solution is, what is my general solution? M1, sorry, 1 to C1 into e to the power 2x for my first term, C2 component corresponding to 3, that is, and what are the components corresponding to M3 and M4 combined? Because they are complex roots, so I need to combine the components. So I have e to the power minus x times C3 times cos x plus C4 times sin x, right? It is x into C1 or Ci times cos px, Cj times sin px. So here value of a is minus 1 and value of b is plus 1. Value of a is minus 1 and value of b is plus 1. We can consider my b as minus 1 also. Right. If I am considering minus 1 minus iota as my first root, then its complex conjugate is minus plus iota. So I will get C3 cos x minus C4 sin x. The sign of minus x is minus sin x. But again, multiplying by a constant, minus 1 is a constant to an arbitrary constant, I will again get an arbitrary constant. So no change. Okay. So solve. Yeah, we would have solved one or two more examples. But okay, we don't have that much time. Actually, we started 20. But I hope you are comfortable in solving homogeneous equation. I will give you some that PDF. Did I share the PDF with general questions? Okay. So practice the sub questions because homogeneous function will you have to solve homogeneous solutions, or you have to go through homogeneous solution in any case. Even if you want to solve homogeneous solution, if you are going to solve, definitely have to go. But if you're even homogeneous solution, you have to go through homogeneous solutions first. Why? Because the general solution for non-homogeneous solution will be written as, well, I will just write that general form. The general solution, the general solution to non-homogeneous LDE is y is equal to YH plus YP. Where YH, I mean solution to the homogeneous equation. Solution to the homogeneous equation, and YP, particular solution. YP means this is solution to homogeneous version of same equation. So whatever the equation is, just ignore the right hand side and solve the homogeneous version of the same equation. You will get your homogeneous solution YH, and YP will be a particular solution. And how to calculate those solutions, we will see in the next lecture onwards. So notice that this YH, the complete solution, will be addition of homogeneous solution plus particular solution, or CF plus PI, where CF stands for complement function and PI stands for particular. Well, I will write down this again in the next lecture. Don't worry. Well, these are some words. Sometimes some literature use YH to represent it as a solution to the homogeneous version for that homogeneous, and YP, P stands for particular. So it shows that it is the particular solution to the given differential equation. And some literature use CF plus PI, which they are following CF plus PI. And the above notation was followed in the George Simmons, which was my graduation. Okay. Well, both notation can be used interchangeably. We'll stop here. I'll end the meeting first so that we don't have to record more much. So where is that meeting? Uh, evening. Today is today. Today's class is in the morning only. Morning only. You will have a class tomorrow if you got any of slot which actually combines. I mean, I can take the lecture to both the classes, not just your. I should I mean clear that I should be able to give at least one lecture to both the classes. So whenever I'm going for these combined versions, we are at the same stage. So if both the classes have a lecture to in, if we are having lecture in that, I can take at least one lecture on each class. Then we'll remove an online session and go for the offline one lecture. If you are not able to do that, then there will be one combined online lecture. So this will be the strategy to cover up the syllabus, and definitely for mostly on Saturday, Sunday, and Monday, we'll go definitely for one online lecture every day. The last three. Monday is a holiday. Monday is a holiday, Ramjani. That's why I said Saturday, Sunday, and Monday. Yes. So we'll stop here.